In this problem, we need to draw a directed graph for relation 1, or R1, and then determine if it is reflexive, symmetric, and transitive. So I'll start with my directed graph, and I have the ordered pair 0, 0, which means that 0 gets paired with itself. So we have an arrow coming out of 0 and then headed back into 0. Then we have 0, 1, which means that we have an arrow going from 0 and into 1. And then 0, 3, arrow from 0 into 3. All right, then we have 1, 1, which means that we have, and this we're going to see in chapter 10 is called a loop when it comes out of and then back into the same element. That's called a loop. And 1, 0. So now we're coming out of 1 and going into 0. So we've got an arrow going from 0 to 1 and then from 1 to 0 because we've got both of those ordered pairs. And let's see, what else do we have? We have 2, 3. So I need an arrow going from 2 to 3. And then finally 3, 3, so one last loop. Okay, now, well, I'll check those off since I got those done. All right, so now I want to determine if the relation is reflexive. So if it is reflexive, that means that 0, 0, 1, 1, 2, 2, and 3, 3 are all ordered pairs in the relation, and we're actually missing 2, 2. So my answer is no. 2, 2 is not an element of R1. Okay. Now, next thing is the relation symmetric? All right. So let's check. What we're looking for is if we have an element, like say 0, and we have a pair 0, 1, then we should have 1, 0. And we do have that for those ordered pairs. And let's see if we do all the rest of the ordered pairs that we have. So I have 0, 3, but I don't have anything going from 3 to 0. So that means that the relation is not symmetric. So my answer again is a no, because we have, what was that again? 0, 3 is an element of R1, and 3, 0 is not an element of R, 1. So remember that the symmetric property is if x, y is in R, then y, x is in R. And this is a conditional statement. So how do we show that a conditional statement is false? We use an and statement. So this was if P, then Q, and we're going to say no, P and not Q. And so that's the contradiction of our conditional statement. And finally, determine whether the relation is transitive. This is always the trickiest one. So what I'm looking for is there a set of ordered pairs such that we have A going to B, like I have 1 going to 0, and then B going to C, could be going back, or it could be going to some other element. So A to B, B to C, and then I want to know, does there have to be, or is there an ordered pair from A to C? And we can see that we can go from 1 to 0, and from 0 to 3, but we can't go directly from 1 to 3. And that's what we would need if it were transitive. So again, my answer is no, because we have 1 going to 0 and 0 going to 3. So those are both elements of R1, but 1, 3 is not an element of R1. So that is our answer for that problem.